We're going to talk about the imaginary unit. Okay, so what you're like, what the heck, right? So we run into problems when we're doing math and specifically when we're taking the square root of something. So after this lesson, we will understand how the imaginary unit is defined. We'll be able to take the square root of a negative number, right? But we can't do that in the real numbers. So we're going to have another number system. And then we are going to learn how to simplify the imaginary unit and how to put a complex number in the form of a plus bi. So a is the real part, and then b is the bi is the imaginary term, and that would make complex numbers. And then we're going to graph that. So the complex numbers are not inside the real numbers. Actually, the real numbers are inside the complex numbers. So it's kind of a little bit, they're like a subset. But anyways, let's go and understand how it's defined. Well, anytime I have I squared, I can replace it with -1 and vice versa. Because when we're looking at a square root, when you take the square root of something, it's asking what multiplied by itself is equal to me. Well, if I take real numbers and multiply by themselves, if I took a negative number and I multiplied by the same exact negative number, I'm going to get a positive number. If I took a positive number and multiplied it by itself, I will get a positive number again. So there's no way in the real numbers to multiply something by itself and get a negative number. So that's where we ran into trouble, and that's why we have to use the imaginary unit. All right, so let's just look at this for a second. Well, we see -4. Well, we notice 4, 2 times 2, right? But a positive 2 times a positive 2 gives you a positive 4, and a -2 times a -2 gives you a positive 4. So neither one of them is giving you a -4. So what we do is we factor it, and we get -1 times 4. Now, you guys don't have to go through this whole thing every single time, but we know -1 is I squared, and 4 is 2 times 2. So essentially, in your mind, you need to see I times 2 times 2. Well, when you have a square root, every time you have a pair of factors, you can take one out. So right here, I'm going to have a 2 coming out and an I. Now, I don't put plus or minus in front of here because the radical is already there. We did not create the radical. So we just use the sign that's in front, which was positive. So our solution would be 2I. If we looked at it this way, there's 0 reals and 2 imaginary units. So you could write it like that, but basically it's okay to write just 2I. All right, let's go to the next one. -8. Similarly, we will take this and go -1 and 8. The -1 goes to I times I. 8 goes to 2 times 2 times 2. So underneath here, you're going to have I times 2 times 2 times 2. Well, that means we're going to be able to take an I out and 2. So today you can tell your parents that you took 2 I's out. Just kidding. Okay, but we were left with a 2 inside. So this is how we can write it. We don't usually go 2 radical 2 and then I, just because we don't want that I to get in there, but it's better form to have the value in front of the I. So just be very careful when you put the radical in front of the I, that the I is not absorbed into the radical because it is not inside. Okay. So again, -50. So this is I times I. That'll take care of the -1. And then we have 5 times 10, which is 5 times 5 times 2. So we will be able to take an I and a 5 out and be left with the square root of 2. All right, so because of this, we can also write this as 5 radical 2 I, but we have to make sure that I is not underneath the radical. I'll accept either way when it's a radical. Wow, I gave you the same example. So let's make a new example here. Let's do the example of square root of negative 14. Well, 14 we can break down to 2 and 7, but that doesn't really help us, but that doesn't stop us from being able to take the I out. So we would have I and then square root of 14. Again, square root of 14 times I. If you do it like this, right, you need to make sure that that the I is not under the radical. Okay, so let's go. Hopefully I have that fixed on your notes later. Okay, we're going to talk about now looking at a complex number related to a graph. So when we are going to graph a complex number, we can't just use x and y because those are how we graph real values in a coordinate plane where the first value is related to x and the second value is related to y. Well, we don't really have an x and y here. What we do have is we have a real number and an imaginary unit, right? So we have a and b. So we have an a and we have a b. So what we're going to do is we're going to put the real part related to the x-axis, and we're going to put the imaginary part related to the y-axis. Okay, so what does that mean? Okay, so what we're going to do is we're going to look at a couple of solutions down below, and we will see. So if I had a plus bi here, the a would have been a 2, and the b would have been a negative 3. So essentially, we are going to go to 2, negative 3, and put our point. And so this is our point A. Again, a plus bi. This a would have been a negative 3, and b would have been a negative 4. And so we would be at negative 3, 1, 2, 3, negative 4. All right, and that would be our b. All right, the next one. Whoa, what happened? There's no value in front. Remember how I told you that that is the same as this? Well, this is important to know because now a is 0 and b is negative 4. So we'll have 0 and then negative 4 for our C point. And similarly, we have 0 plus 7i. So we have a is 0 and b is 7. So 0 and 7, and that will give us our final point. Yay! Okay, so hopefully you understand graphing complex numbers where we have a real axis and an imaginary axis instead of x and y. Okay, now we're going to talk about simplifying these, right? So when we look at this, wow, this is poorly done, but it's okay. I to the 0 power. Well, anything to the 0 power is going to give you 1, right? We already know that I squared is going to give us negative 1 because that's how it's defined, right? And I is just going to be I, right? We're not really changing that. But when we look at I cubed, this is I times I squared. Well, we already knew I squared is negative 1. So when we take I times negative 1, we are going to have negative I, right? So far we have a 1, an I, negative 1, and negative I. Okay, the next one, I to the 4th. Well, I to the 4th is like taking an I and multiplying it by I cubed. So this is I times negative I. So this is negative I squared, but I squared is negative 1. So we have negative 1 times negative 1. So we are going to get a 1, and that's really messy. So let's just erase that. We're going to write it a little bit neater. Because another way to look at this is just I squared times I squared, which is -1 times -1, or 1. Now you might have noticed that we kind of started cycling. Here we had 1i, -1, and -i, and we've already got a 1. Let's go to another color. So I to the 5th is going to be I times I to the 4th. Well, I to the 4th is just 1. So this is I times 1, or I. Well, look, I was already at a 1. I already had an I. You see how we're going in that pattern? Because that pattern is just going to keep continuing, right? I to the 6th is equal to I times I to the 5th, which is I times I, which is I squared, which is -1. Look, we had a -1 there as well. And then we keep going. I to the 7th, and then I times I to the 6th, I times -1, and then that's going to be -I. And here we go. And if we keep going, we're going to keep going with that pattern. So how do we do that and find something like I cubed? Well, I cubed is pretty easy. I times I times I, right? So we group these two together, and we know that that's -1. So we have I times -1, or -I. And we showed this in, and I don't like writing the I like that, and we showed this in our little table over there, right? Okay, that's the simplest form of I cubed. We do not want to have an I with an exponent, okay? I should not be left with an exponent. Well, here's something interesting. When we look at this, we can see that I to the 4th is equal to 1. I0 is equal to 1. And if I went one more down, guess what I to the 8th would be equal to? That's right, 1. So can you guys see everything that's a multiple of 4 so far is going to be 1, because that cycle continues. Well, let's talk about that for a second. What does that really mean? Well, I can look at 22 and ask myself how many 4s are in 22. So that's actually 5 remainder 2, right? So let's talk about what that means. That means I can make 22 by going I to the 4th, I to the 4th, I to the 4th, I to the 4th, I to the 4th. So there's the 20, and then the leftovers. Well, all these 4s don't really mean anything, because I'm just going 1 times 1 times 1 times 1. The one that means something is that leftover. So this is just I squared. Well, do we leave I squared? Nope. We know I squared is -1. So this is going to be 1 times -1, or -1. Okay, cool. Well, do I want to do this over and over again? No, I don't. So once I find out how many 4s there are, I know that all of those are absorbed to make 1. What I'm really worried about is the leftovers. So let's take 4 into 36. Well, that goes perfectly. Remainder 0. So that means there are going to be 9 of the 1s, which doesn't make a difference. And then I have my remainder, right? And so anything to the 0 power is 1, so this will be 1. Let's try one more. Try to pause and do this one and then see if you're getting it right. I'm hoping you do that with a lot of my examples. Okay, so again, 4 into 221 is going to give you 55 remainder 1. So these are absorbed and make a 1, right? But the thing I'm really worried about, or concerned with, or whatever you want to say, is the remainder. And so this is remainder 1. So this is I to the power of 1, or just I. So I to the 221st power is the same as I. So what do? How do we summarize this? We're going to take 4 and divide it into the exponent. And then we're going to take the I to the remainder. So we just need the remainder. We don't need the other stuff. Okay, I hope that helps. Take care, you guys.